Okay, it's a pleasure to me to introduce you Mitra. He's an editor of Physical Review Letters. To tell us about how is Physical Review Letters today, and some advice about how to publish good research in Physical Review Letters. So he's a physicist. He did his PhD on quantum Hall effect in Bloomington with Alan McDonald. And then he had some postdoctoral experience on chemical physics. And then in 1996, he became editor of PRL. So, yeah, so thank you for being here.
Okay, thank you to Rosa in particular, and to all of you who have invited me to this wonderful island. Anyone I tell that I'm here, they always think that I'm going to sit at the beach the whole day. But, it's you know, I think that's what I do. Right. including people in Spain, they think that. Yeah, so I'm here visiting various institutions in Spain. Talking about so it's kind of like a two-way street. So I like to tell you something about the current state of the journals, what we do, and it's kind of a free-flowing talk in the sense that there will be at various points I could just stop and talk about other things, move on. But I would very much appreciate it if I get a lot of questions. It's not a talk that has to finish. I have to get to the end. We can stop at midpoints. And I think you said there was going to be an informal.
Yeah, I forgot it.
Yes, so
tomorrow we had an informal meeting with Xiaomi about how to write a good PRL paper and instructions and advice for students. So it's more focused for students.
And that will be
at 10:30. Depends on the audience. Maybe here.
Anywhere, that's not you, whatever, and that.
I will make the official announcement.
And that would be required for students.
And also everyone.
Anyone, that'll be more informal.
And students is required.
And I would, that'll be more of an informal question and answer kind of session. Here I have a few slides which I can skip over or not at the time when it comes. But obviously in the session tomorrow I'll be open to answering in more detail anything that you require. So just to give you, so this is the title. So to proceed, so it's interesting, I found this quote from Rudolf Peierls, and this was in 1961, and I'll let you read the quote. So, as you can see, the present just to fill bookshelves exceeding that of light. But as he said, it's not a problem because physical review transmits no information. But the interesting thing to note is that he said this in 1961 when all of the physical review journals, and PRL did exist at the time, but not all of the other, like Physical Review E was not there at the time, received 1,800 papers. So in fact, I believe in 2013, the Physical Review journals published 10 times that many papers and received about 30,000. So that's the next slide. So times have changed. And of course, the interesting thing is the concept of bookshelves itself has changed. I think that's more recent because I probably by a show of hands, which I won't do, many people in this room will probably not have seen Physical Review Letters as a paper entity. Is that true? And that's so here are some numbers for you. So in the 2013, that's the last complete year, and this is all of the Physical Review journals received and published. Those are the numbers. So, and that's a big set. So we comprise 3% of the world's so-called physics journals. Of course, as we were discussing in the morning, what's a physics journal is not particularly well defined, but this is this is from the organization that produces this information to librarians. It's not from And then 15% of all physics articles that were published appeared in these journals, but more importantly, 30% of all citations received by physics journals came to our site. So it's a big presence, not in the absolute number of journals, but in terms of the overall published entities. The other thing that has changed in recent years is that these journals are truly global. And in particular, this means that over 2/3, and 2/3 is a conservative estimate, in many cases it's 70 to 75% of the papers, the referees, and the money that comes in, all of that is from outside the US. So it's truly global in that sense. So it's the journals of the American Physical Society, that these journals have a much bigger presence now in all these respects outside of the US. Now PRL in particular has a particular balancing act that the editors of the journal like to do, right? And we talked about this morning. So we have these four kind of attributes we're trying to balance, right? So we want to be fairly large. So we don't want to be a small elite boutique journal. We want to be fairly large. But at the same time, we don't want to be large in just one field. So for example, Physical Review B is bigger than us, but they're mostly condensed matter. Whereas PRL wants to have breadth across all areas of physics. And therefore, this one is, representation is the third word here. By representation, I mean that for any given area of physics, we want to publish enough papers in that area so that people who are in that field feel that their field is well represented. Which means that if we were super selective, in some areas of physics, you would see maybe one paper in a year. And that is not representative. So that is part of our challenge. And at the same time, we know why people publish in elite journals. That's because they want to belong to an exclusive club. So, for various decision-making processes that happen at universities all the time. So one of our challenges is that we want to offer this stamp of exclusivity also. So those are the four challenges we have to balance. So size, of course, this is an old figure, and you can see this is from 2012. So this is a month's output of PRL. And for those of you who haven't seen the physics, the PRL on paper, this is it. This is your chance. And the interesting thing is that that phone there was not an iPhone 4 at the time. So it's bigger than an iPhone. So you can see it already was pretty thick. But as it turns out, the journals have actually grown smaller, which are slow. So this is roughly what it was at the time. So its size, certainly, the point of showing that slide is that size at the time was substantial. But PRL is getting smaller. This is from a colleague of mine who just generated these slides. So we kind of went through a bit of a phase transition, and it turned out to be much sharper than we had thought it would be at the end of last year. And so you can look at the year-long time windows before and after. So PRL, which was close to 4,000 papers the year before, my thinking is that in the year 2014, we will have published about 2,500 papers. This is, maybe a little higher than that, maybe 2,600. So that's a substantial drop, and this is by design. Now the numbers that he has below, highlighted letters, I'll come to that a bit later. This is basically, as you know, Physical Review Letters chooses a subset of papers every week for what are called PRL suggestions, and some of them are highlighted in this online entity called Focus, Physics and Focus. So here we are talking about, I think, maybe 7 or 8 papers a week is what falls into this category. And that number has kind of stayed constant. We highlight papers not based on any kind of numerical scheme, but things that seem interesting or important enough to editors, and that number has roughly stayed the same. All right, so this is a busy chart, but it gives you some information. So this shows you the acceptance rates for the journals of the APS and how they have changed over the last 2 decades, right? So you can see that PRL has steadily dropped. At this point, this is one of the, we had consciously dropped it. It went up again for various factors I talked about, and we're dropping it again. And the latest number is somewhere around 20%. PRL. This, for example, is Physical Review C, which is a high acceptance rate, but it's a small journal and it's kind of stayed where it is. Sorry? Yeah, so Physical Review D is similar. Of course, these are percentages, not absolute numbers. So Physical Review D, as we know, is a much bigger journal than C, but the percentages are what they are. PRB has dropped a bit over recent years, quite a bit, as you can see. So they dropped from roughly 70% now to about 50%. That's Physical Review B.
And any number for Physical Review X?
Physical Review X is very small. In the sense that I think the acceptance rates, I don't know because they don't have the full years, but I'm guessing it's maybe 15 to 20%. Of course, the number of papers they receive has not reached steady state. So, now Physical Review X, I think their aim is to keep it at a very small number in terms of published papers. So if the number of submissions goes up dramatically, they'll have to come up with some scheme to reduce the acceptance rate. But they haven't reached steady state yet. All right, so this is PRL, basically the same thing. You can see in 2012 we published 73, 60. This year so far we're publishing about 50 some a week. Now this, of course, this 50 is where we believe we have the pretty good balance between the 4 attributes I referred to earlier. We believe if we go down to 30 a week, then some of those we will cease to be representative in certain areas. So that we shall see. All right, so that's a question. We'll skip over for now. All right, so this is the percentage distribution in 2012. So this may have changed slightly. So you can see from here that Physical Review letters, especially if you ask people who are outside the field, is largely a condensed matter journal, right? Because that's almost 45% plus this to people who are not in condensed matter or soft matter. If you ask a particle theorist, they'll say this is also condensed matter, right? So if you think of it that way, basically Physical PRL was about 60%. These other areas, and so these are the other components of the journal that are clearly defined. My sense is if I ran these numbers at the end of 2014, the fraction here will go down somewhat. Fraction here will go down somewhat, but these two probably will stay the same.
Sorry, which one will you cut?
Sorry?
Which one will you cut? Sorry.
Well, I mean, I think in general, when you're cutting the overall journal, my guess is this is probably getting cut a little more than here. All right, so this is a small slide I had just in there. So one of the reasons is I showed this up is that there's a journal like Physical Review Letters, which publishes in all areas of physics. There's always a temptation to, because we're so big and we publish so many papers in all fields, to publish in one field compared to others. To give you an example, this is the profile of graphene and PRL excluding the last couple of years because you don't have the effective impact factors for those years. So you can see graphene was essentially non-existent before 2004, but then we received a lot of papers. So these are in 2010 papers received in 2008 and 2009 roughly, and that number would have been about 100 a year, right? 150 a year, 120 a year, because that's 2 years worth. So that's a substantial number of papers for a small field. Enough that you could almost think of it as a separate small journal. Now the effective impact factor for papers on graphene in PRL was about 15, right? That's a big, but of course one doesn't see that because it's published as part of a big journal. But there are subsets of the journal which are substantial in terms of volume, and substantial in terms of citation profiles and so on, but they are all part of a big journal, a big community which has that. So for example, when nictide superconductors were a big story and highly cited, we were getting a very large number of those, and that's changed. So things come and go. All right, so one of the points I'm trying to make here is that PRL is one journal, but that addresses many different communities. And so if when I give a talk like this to, let's say, a plasma physics versus networks community, they're completely different as to how the journal is viewed by those different communities. The publication numbers, acceptance rates, so on and so forth is very different from theoretical to experimental physics. To give you an example, I think in the area of two-dimensional semiconductor transport, for example, the acceptance rate of experimental papers is almost double that of theoretical papers. So, I mean, it's possible that we receive fewer experimental papers also. So there is that. The perception of the journal to the condensed matter community versus the high-energy physics community is vastly different. From everything, from money to what are published, what kind of authorships there are, everything. So it's a whole different... so the reason is, to change the journal becomes difficult because you have to address all those. Right, and then now, of course, we are in a very competitive atmosphere. This is the issue of exclusivity we talked about, we mentioned briefly, and I can answer some of these questions if you have questions. At any point, please feel free to stop me and ask me about any of this. But these are all these various metrics that are floating around, and it's difficult to say what's more important than another. Turns out in the year 2014, the journal impact factor is the determined, people talk about it. But if you go to Google, they have a page where they list the so-called H5 index. So if the H5 index suddenly became the important metric, then certain, the perceptions would differ. And so there are all these various things people play with. But the point is that, as with many fields, this is a complicated short-term game that we have to play with, but be careful how to play with it. All right, so this, of course, as some of you recognize, is the French Academy. And the reason I put it up here is that somebody said that anytime you have a highly selective club, whether it is this year's Nobel Prize, where I don't know if you have kept up on the large numbers of high-profile folks who are claiming that they had just as much to do with gallium nitride lasers as the ones that got the Nobel Prize. So you have to make a cut somewhere. So same with journals. Anytime you publish a small number of papers, there are papers just beyond the edge which are just as deserving as the papers that are inside the room. Right? And that's always a challenge. So this is an interesting article. If you're interested, you can. All right, so we talked about, so this is what the question is, whether breadth across fields or within a field is mutually exclusive when you're trying to be selective. Selectivity and breadth. All right, so a little digression here. I can go into more detail tomorrow. So this year, a little short digression about the PRL review process. So I think this is the perception that people have. Is it not that bad? All right. So this is Sam Goudsmith, of Goudsmith and Uhlenbeck fame, who was the first editor of Physical Review Letters. And this is a quote that he had. And there you have it. So the point is, any given paper, the review process may or may not go so well, but on average it works out. So this is what the PRL editors. The editors of PRL, when papers are submitted, and this I'll gloss over, but tomorrow at the Q&A you can ask me about any of this in more detail. So we're looking for these things, right? Whether the paper reports. These are, each of these are, individual things which are not, it's all subjective as to whether it does it, but these are the 4 criteria we look for in a paper. Not all 4, but one of these 4. So it's an or, not an and. So the basic question is, for any paper that we receive, since we have journal specialized in the field. So for example, if you receive a paper on some kind of transport characteristics of a gallium arsenide sample, we know that Physical Review B, for example, publishes papers on the same thing. So there has to be something in the paper that tells us, the editors, that this paper should be in PRL and not in a journal in condensed matter physics. And that something should be evident to the editors from the paper itself, from their knowledge of the field, from referee reports, whatever. And then we have done some changes along these lines that you may have noticed. And starting last year, we asked authors to make that case for themselves. Right? So we ask authors, when they submit to PRL now, they have to provide what we call the justification paragraph, where they basically make a short sentence. The argument here is that sentence should be persuasive to a physicist colleague of yours who knows nothing about your field. And that we look at it. I mean, the editors usually know what that is, but this kind of makes it clear in the author's mind what the argument is for PRL. And of course, the author with any submission is probably looking for these 5 things, right, when they submit to FISC letters. They're looking for rapid and fair review, because I have a qualifier here. So when they say rapid, they mean if the decision is positive, because we reject a lot of papers, as I'll show, without any review whatsoever. That's very rapid. But authors don't like it because it's always negative, right? If that early decision is going to be negative. So there's that. Fairness. They hope that the review is going to be fair. Validation. By validation, I mean that used to be that journals were responsible for disseminating the information, but that's no longer the case. So for example, there is no paper, particularly theoretical papers in Physical Review D, that has not existed on the archive for weeks before publication. So the only reason that it appears and gets published in Physical Review D is because it gets a stamp that says it's correct if people have looked at it. So there's that. Exclusivity I mentioned earlier. Highlighting. This is, for example, earlier today we saw a paper on the voter model, which, for example, got picked up by the press. It appeared in Focus and so on. And none of that is accidental, because the press folks don't go look at everything. They only look at what's kind of, for the want of a better word, fed to them by the journal. So they look at, because it appears on Focus, and there are these so-called distributions, listservs, now Twitter, so on, that they subscribe to, they pick them up, and that's how. So the journals have this mechanism to distribute it to the press. So there's the highlighting mechanism. And that comes with wide visibility also. I mean, the visibility, anybody can write a wonderful, correct calculations, and they're often on the archive, so they go across a wider set if it's published somewhere. Even if they don't access it by the journal, but the fact that it's been published is key. So here's a busy slide for you. This is the percentage of PRLs that are rejected without external review that I referred to earlier. So you'll see that here in red are the percentages of papers that are rejected without external review upon submission. This number, again, was high in 2009. It had dropped, and I believe it's about 35% for 2014. And some subset of them are submitted back to PRL, and then a subset of those are published in PRL. But that's a very small number, and this is what we had I discussed with some of you earlier this morning, is that if a paper is rejected without review by the editors upon submission, and some of them are rejected by the editors, some are rejected by the editor upon discussion with the divisional associate editor. Now PRL, like all the Physical Review journals, allows you to resubmit. But you have to ask yourself that if this is the success rate after resubmission, is it worthwhile resubmitting to PRL, or should you not submit to some other journal? So that's a decision authors need to make. All right, I'm going to skip this. Go back here. This is just to give you an idea of what happens to submissions to Physical Review letters. So roughly you can see what this is, a busy slide, and you can see later on. So one of Here's a subset of papers that are published. This one ends in 2010. This is a busy enough slide that I was unable to generate more recent numbers. But you can see what some of them are rejected without review and they don't go back. And this, the important thing is this one. These are the subset of papers that are transferred to physical review and then published. So 30% of rejected PRLs end up in physical review and get published. Rapid communications, the number is much higher, for example. I believe 2/3 of physical review B rapid communications are papers that they receive from PRL. Okay, this is a busy slide. I'll skip this today. Tomorrow, if you have questions, I can answer. Skip that. That was to show that it was complicated. If you thought PRL was complicated, there you go. All right, some small words about our referee database. So we have a very extensive referee database. This contains over 60,000 active referees, which means they have reviewed something in the recent past. 500 new referees are added each month now, and this number has grown because of the availability of information about people's publication records, especially from areas where there was underrepresentation of referees before. Used to be it was not easy to find out what people did very quickly, but now you can, thanks to Google Scholar, Web of Science, and so on. So it's easier to figure out what the expertise is of a potential referee. And then once they're in the database, of course, we have very detailed records, entries about referees. You can see the interesting thing here is that there's a very small number, about just over 1,000 referees who review more than 10 papers a year. So some small subset, as with all distributions, there is a head and a tail, and the head here happens to be those highly consulted referees.
People reviewing 10 physical review letters per year.
No, I don't think it's physical review letters. This has to be all of physical review.
Okay.
All of them, not just physical review letters. In fact, most referees, most of the referrals they receive are probably not from PRL, but from. All right, so this is the thing somebody did this. You can see this distribution. It shows you the same information in a different way. I think we can skip this thing. All right, here's some new statistics somebody generated. The interesting thing here is that the American fraction of referees has largely stayed constant in recent years and dropped in relation to other areas. So most of our referees since the early 2000s are from Europe. And there's a fraction in Japan are growing. I think the big challenge is that China has an underrepresentation of referees, but I expect that to start changing more and more now. And I say underrepresentation because the fraction of papers coming in from China has sharply increased. Fraction of good papers coming in China has also sharply increased in just the last 5 years. And so, the authorship increases, refereeing has a certain lag as they build up an authorship record, and so I expect that will change. All right, and so this is true for those of you to give an idea of how long the papers are, where they sit, and so on. So you can see that in our defense, the office has actually become more efficient in recent years. So we used to, the average, this is the total number of days spent by an average paper over the course of its existence in the system. So if a paper gets quickly published in one round, that's a small n, but now one thing I'm forgetting, I think this chart, doesn't say here, refers to published papers. So this is the numbers for papers that are actually published. So it does not include the paper which the authors might continue on the review process for a long time and so on. This is the component that is with referees. It's very difficult to bring this down more than, because the referees are busy people. We can push them only so much, not more. This is, of course, the time the authors take to resubmit the paper over multiple rounds and so on. This gives you some idea of where the latest refereeing published comes from. So you can see that the USA is submitting about a quarter of the papers, getting published slightly larger percentage. Europe is significantly more, and the published fraction is even more, as you can see just from the pie chart here. So, in other words, I think that the acceptance rate of Europe is slightly higher than America.
Where's China on this graph?
China, I believe, is this. Right. Just from thinking from here.
And the third big fraction, the other one, who is
This one?
not the
Blue
blue,
one, the blue one, the one above, one light blue.
light blue.
Light blue would have to be. I've got another chart, I have to look it up. Maybe I'll answer later on. I took this out because it was getting very busy and we wanted to concentrate on USA and Europe, but now I have exactly. I'm guessing it's most likely Japan, but it may be Japan combined with Australia. So I have the chart somewhere, I have to find it. All right, another thing. So just to give you an idea, we're talking about this. So what do we offer? I mean, one of the things is we have this big machinery which moves through papers at a certain, large-scale industrial fashion by necessity. But of course, for some papers, for small subset of papers, we can be extremely hands-on approach, move things quickly, and we do it sometimes. So for example, if in any field, certainly if there is a clear sense that this paper, in the sense from the authors or from other people here, is that this belongs to that very small handful of papers that deserve to be not only published, but published quickly, and there's almost zero chance that it will not be published, and it will create a lot of waves in the field. We are willing to move very quickly. But that it is a very resource-intensive approach, and we can only apply it to maybe at most 5% of the papers, maybe smaller than that. So to give you an example, here's the paper. This is the cosmic ray experiment from the space station that was in 2013. This paper was received on the 14th of March. It didn't come out of the blue. People knew that it was going to come. And it was published, in just over 2 weeks. Not accepted, but actually published. So the production and everything happened. It simultaneously got a physics viewpoint and a suggestion, which was then coordinated to appear. So the physics presumably was being written before the paper had been accepted, right? So this kind of thing can happen. But you can imagine this is not easy to do. And this editor, whoever handled it, would not have done this for some paper that the author's claim was important or something like that. So this is something that can be done, and this paper got a huge amount of press. To show you another example, the operator is some, very few, I should say few. Here's another example. This paper got a big splash this year. This is the so-called BICEP 2 paper that appeared this year, which is now all the stories have changed. But this paper was, it was a 20 plus pages PRL actually. So this paper was submitted to us on the 4th of April. I think the authors had held a press conference before, and it was there was a huge amount of presence on the social media and all kinds of. The paper then was revised again in between, and it was published on the 19th of June. And the published version, and this is why journals are important, the published version is quite a bit different from the initial uploaded version on the archive. So it went through a process and so on, but this was again one of those papers which required a very large amount of editorial resources to get it out there. But some of this kind of scenario is more difficult in condensed matter, right? Because with big, large-scale experiments, like whether it's the BICEP 2 experiment or anything coming out of a large collider or LHC or so on, people who are in the field all over the world know ahead of time that the results are about to come, and they have a clear sense of what the importance of the results is going to be. The drama is whether they can get the results. But once they get it, whereas in condensed matter it's very difficult to know upfront which the big experiments, all results or advances are going to be even 6 months from now. You just don't know that. So it's difficult to do the same kind of thing, but one can try. All right, so this is something that I'll briefly mention here, but so you can keep this in mind, and we can talk about it in more detail tomorrow if you have questions and answers. I'll happily. You can tell me what you feel I should be doing, and so. So I'm not skipping this. Is that okay, or shall I skip it?
No.
All right. So this is the problem of all physicists, as you will recognize. So the physicist's problem is that you have trouble conveying whatever you're doing to somebody who is not only a non-physicist, but somebody who is outside your field. So much so, in that PRL celebrated its 100th year, Physical Review Journal. This is the New York Times coverage of Physical Review, not PRL, Physical Review, reaching its 100th anniversary. This was in 1998. So there you go. So there you go. And this is something I'm sure you'll all appreciate. This is true. So this is the challenge you have at various levels. I mean, the one challenge is, of course, to walk, if you're going out to your favorite wine bar, how to explain to your sociologist friend or somebody who is doing something completely unrelated to what you're doing, what do you actually do and why is it important? If you're doing cosmology, maybe this is easier because they've all read Brian Greene or something. But if you're doing, the search for Majorana fermions in nanostructures, it's very difficult. So that's the first challenge. But the other challenge is to convince other people that are more important in that level. So the first advice I have is this book. I don't know if any of you, are you familiar with this book at all? So you should get this book. It's a very short book. And if you don't want to buy it, it's, I guess it's not Creative Commons, but it's the Gutenberg Project or something. It's freely available now. You can download it for free. And the most important lesson from this book is this. Omit needless words. But the rest of the book has a lot more wonderful stuff in it. So, now this is controversial. Some of my colleagues don't like this book. They think it tries to make everything simpler than it needs to be, but that's not. Another thing I was talking about it, and I'll mention it tomorrow. Don't worry. Go back here. So one of the things that physicists always have is they always use a lot of acronyms. So, this is very common usage. I'm sure Rosa knows what this is, right? But you should go and ask your other physicist colleagues and see how many of them know what this is. But people working with nanotubes think this is common knowledge, everybody knows what it is. Not true. So there are routinely you will have, so this is just a reworded, fairly scientific version of that first statement. So this is always the test, is this acronyms means that these are people always, I think the term that you call is jargon. Make something which is immediately clear to somebody sitting in your lab or at the small conference that you went to the month before, but not to other physicists. So that's something to look at, and the easiest test is to just have your paper be read by somebody who is a physicist, but not in your field when you submit it, or before you submit it. So this is something I mentioned before. At least the introduction, not the rest of the paper, should be accessible to physicists who is not in your field. And that's how it should be written. Okay, now a few words about referencing. So this is, of course, PRL decided to change its length count. So for example, now we don't count the references because we felt that people, in the pressure to fit everything on 4 pages, they would like to put in 20 references, but they reduced it and put only 10 so they could use that extra paragraph to write the paper. So adequately reference previous publications. Generous, you have to always ask yourself, is your paper maybe reviewed by one of those referees whose papers you forgot to referee, but not really good. Cite current related work, and here the operative word is current. because when editors are looking at the paper, they want to see that there is ongoing activity in the area of the field. So there is an important problem, let's say, but the last time people addressed that problem was in 2002. So the argument that your paper, which is submitted to us in 2014, now solves that problem means that this is not only a problem, it is so important, it is unsolved but significant enough that people didn't solve it for 10 years, not because they were not interested, but because they couldn't do it. That's a high bar. So that's the kind of unnecessary self-citations, important, of course. If not, you stand on the shoulders of others, as they say. And do not oversight. You don't want to, a PRL submission with, 150 references is too much. It's a letter, after all. So this is some things. Simplicity, that was the first one. Grammar, spelling. I mean, these are all important, minor details, but in this day and age, for the very basic thing is you don't want to send in a paper that the editor cannot send to a referee just because it's full of simple mistakes, because then the referee will just fixate on that, and that will, creates a negative impression. There is no reason to submit a paper with that kind of error. You should just ask somebody, if you're not comfortable writing in English, there are enough people in your department that you can just ask them to look at it, and you can buy them, a bottle of wine. This is what I mean is by impressions matter, and first impressions matter more. Okay, so then there's the cover letter, which you're submitting, it's an online cover letter. So first thing you have to ask yourself as you're doing it, why are you submitting to PRL in particular? What did you do? Now this presumably is going to be clear from the paper itself, but even if you didn't have it on the paper, it should be clear on the cover letter. And this is something I talked about earlier to some people in our physical review letters and all the physical review journals. There are boxes, or there are free-form boxes in which you can recommend names of people you think we should consult and names of people that you do not want us to consult.
But you can propose names of people that you don't want to include in the
Right.
review process, but because you consider them as a competitor.
That's fine. Yeah.
That's,
so as an
that's because of that, not because there is a
No,
relationship or whatever.
You can do whatever. I mean, I think there are a few people that you would not want us to send the paper to, right?
Yeah.
Maybe they're competitors, maybe there's some other problem. That's fine. You should tell us. But if you send us 20 names, then it's no good. And I've had cases where we have papers that says, please do not send this to anyone in Western Europe. Right? Now, it's possible that the author who is submitting it is in an experimental group, and maybe there are 2 experimental groups or 3. One of them happens to be in Western Europe. But instead of saying, please do not send it to anybody in Delft, they're saying, please don't send it to anybody. So that immediately, as an editor, to me, it means I shall ignore this input, right? I mean, so you have to be very precise. A few names, we'll almost always make sure that we do not actually consult them, because there's no point doing it. And also, if you think you want us to seek input from some people, that's always good. The 2 or 3 things to remember: do not cite only the names of the most well-known scientists in your field, because everybody knows who they are, chances are. And also, if you suggest 10 names, and we quickly see that 5 of them were co-authors of yours in 2013, that's no good either, because then we'll ignore the rest of it. So that's the way to think about it. So ideally, you're suggesting names of people who kind of work in your field but not with you, and who've done this kind of work recently. And this is something that you should point out. If you think there's a competing group, again, it cannot be all kinds of competing groups, but some immediately.
And do you then store this information and use it for something?
This particular information we will not store. It's stored on the paper. So as the paper goes through the review, but it's not something that's carried on from here to here. But sometimes, if an author says, do not send any of my papers to so-and-so, by name, then we might make a record in that referee's entry which says, do not send any papers from these authors to the referee. But the problem with entering that kind of information is often that information may be valid, solid information for 2014, but as collaborations move and people move away, we don't want that to affect decisions 5-10 years from now. Okay, now you have to write the justification. We talked about when you have to submit the form. The important thing is to be short. And I don't remember, like when I went to school in India, we used to have courses in English called Tracy writing. Do you do that here? No. So that's this was used to be in school that we would get a passage and the test would be to rewrite it in 50 words or less. We'd have to do it all the time. And I think that's very useful. So basically, the justification should be no more than 50 words. Whatever you can do, you write 100 words, but the thing is it has to be under 50. We don't have a hard limit like 50, but I think there should be. All right, so this is true, that readers are always busy, and the important thing is, regrettably, this applies to referees. So the thing is, they're often looking at the abstract. Don't forget that many of the readers, this day and age, they're looking at the archive or some kind of feed, email alert or something. They're looking just at the abstracts and stuff like that, and they're going through it. They're not going to look at the papers. They're going to look at the abstract, and if they find it interesting from the abstract, then they might click on the paper, your paper. Certainly true on the archive. Otherwise, they're just going down. They're going by the names of people they know or by what the abstract is. So the abstract is very important. Maybe sometimes they're just looking at the title. You have in feeds, you have compressed views, which just list the title. And so the title is all they're going to look at. And now people looking at the paper are looking at the introduction, but then often they skip to the figures. I certainly know that people, when they look at articles and PRL, but nature physics and so on, they look at the figure captions maybe, and the figures, and they decide whether they should look at the paper. So that's all important stuff. This may apply to referees. I mean, we don't want referees to judge a paper by stuff like that, but if they do, and you're the author, then it's in your interest to have convinced the referee just from those things. And sometimes to editors, right? Because if you look at the numbers, we have 12,000 submissions, 15 full-time editors. They're not going to read the whole paper. So they're going to try to get the quickest, best impression they can get. So they'll look at stuff just to get that quick impression. And then if they're interested, they might go deeper. All right, so next step. So you've had the paper, it's submitted, it's not been rejected without review, it's been refereed, and now you're resubmitting it for round 2. So again, keep it short, because no one wants to look at too much stuff. I'm talking about the resubmission letter. You have to respond to the reports in detail. I mean, it could be that you think the reports are no good, not fair, but then you have to tell the editors, possibly also to the referee or other referees, why it's no good, why it's not fair, why did it not do a good thing. You have to be polite, because you always have to assume that even if it doesn't go back to that referee, it's going to some other referee. And referee B will not like it if the author is saying mean things about referee A. That's the thing. Described revisions, because sometimes people will we made a lot of revisions, but it's unclear. And if the editor has to look very carefully, comparing words and all, they just won't do it. So it's important to describe the revisions. And if you want to make confidential comments with editors, there is a space for that, you should. Like, in other words, if you think that we should absolutely not go back to the referee, and you want to make some statements about not the face value of the report, but why you think there may be other concerns about collaborations or this or that, you can make that in a separate statement. There's space for that. Now, this is responding to reports. First thing is somebody said sleep on it. I think that means the term's here, right? That means take your time. Don't do it right away. You'll be surprised, several times a year we get a message from one author responding to a co-author that they mistakenly sent to the author. And they will say things, which is, they wouldn't say it the next day. Let's put it that way. Be collegial. Now, this is important. A resubmission letter that's longer than the paper itself is not good. We often have this. So in other words, if you have to make your case in 20 pages, when the paper itself is 4 pages, not a good thing. That means the editor is thinking, oh, should this not be a longer paper then? You know, that's the, because that information that you're making in that great detail is not going to be available to anyone other than the referee and the editor. And that's.
I have some examples in that my response was longer on the paper because the referee reports were much longer.
Yes.
But yeah, that's true. But I'll tell you why that for the referee it's less important. I'll tell you. So a paper should make a better case for itself than the resubmission letter. Of course, in other words, you know, the resubmission letter is like a guide, but the paper is the only thing that will be available to the outside world. All right, and this is the reason, right? So the point is the referee doesn't care whether your paper gets published or not. You care as an author. So it is really in your interest more than anyone else's. I mean, there is a small subset of authors where it is in the journal's interest also to publish the paper, Bicep 2 being an example, right? That the journal would really, really want to publish the paper. But in most cases, it's the author in whose interest it is most to publish the paper. So so it could be that the referee is not a very good referee. It could be that the referee is not understanding. But the default mode for the author, if the referee doesn't understand, it's no good for the author, right? So the author has to make it clear too, because the author is the one who wants the paper published. Okay, I'm nearing the end, and there's a whole little section which I won't get into, but so one of the things I wanted to mention, I just wanted to show this paper which appeared fairly recently, is this paper, you know, we have all these highlighting mechanisms. I think this is a paper actually, I think I was aware of it as it was being submitted, something. So this got published recently, and it got so these highlighting mechanism, it got a cover image. Even though we say that the cover image is pure aesthetics, it does not depend at all on the physics behind it. But we have found that just the fact that the paper has a cover image matters quite a bit. So there's that. And then, of course, we have others, suggestions, synopsis, highlights. So there are these various possibilities. You can see. Now here, of course, this is the title of the table of contents. But the fact that this is a featured in physics and an editor's suggestion. This one I don't believe was. No, this I think was featured in physics. But that means this one is generating its own feed somewhere. Some people are subscribing just to that feed. Some people are getting a feed right of this. So these are mechanisms in which papers are. So there's some journalists are subscribing to this. So, you know, that's how the papers are getting out. So these are tabs which appear on the table of contents, but it also means that these papers are getting highlighted through different channels. And so that's So this is a brief few words about physics. Physics.aks.org. So the 18,000 papers are published, narrows down a funnel, 250 comes up. So they get about 100 viewpoints, 2 a week. About plus 1 focus, so that's about 50, and they have about 200 synopses. So this is a small subset of papers that they therefore can highlight and gets publicity in various ways. So the papers are chosen here by the handling, the editors. They notice the papers are nominated, different journal. This is no longer true, but they talk to other people, and then the editors of physics determine what appears in physics. So the journal editors pick the suggestions, and in some areas they have just as good play. All right, these are some small philosophical questions at the end. So in this day and age, why do we have journals? 5 minutes. And then in the Q&A, you asked a question about physical review X, which ask me after I'm done. All right, so this was interesting, right? In the 1950s, the process of writing a paper was complicated. Just the physical act of producing the paper was difficult enough that it threw off many people. They didn't want to. So people published fewer papers. It all changed with the arrival of LaTeX. Tech and then LaTeX changed everything. Now you can just have one template and generate, as long as you do the research, you can generate as many papers as you want. So that changed. it's kind of similar to making a movie in the year 2010. I remember before the arrival of these small devices, even in the age of camcorders, making a home video was a big pain because you have to move that tape around, put it in somewhere else. How do you get it on the computer? All of that changed, I think, with the arrival of these small things. This doesn't exist anymore. But now with the camera, phone, video, creating of a video, uploading it. So the physical act of creating that video is so easy. So people, it's the quality of the video is a different aspect. I mean, what's behind it, but the act of producing it has become simple. Same with papers. So our job as journals is no longer the fact of creating the paper or disseminating it. It is basically tackling this information overload. That's what it is. So which means, and these are some of the words, so one of them is the countering the echo chamber. So the echo chamber is a term where basically specialists are talking to other specialists and just closed in their own echo chamber. Things in journals, to give you an example, is the fact that this is the quantum information community and the quantum dot community talk to each other is largely because they accidentally started seeing each other's papers and what they did and what they didn't do. Otherwise, before that, quantum information was purely, I believe, more of an atomic and molecular physics enterprise. Not so much, decoherence effects in quantum dots and so on and so forth. So that has changed, partly because of the arrival, being able to, necessarily through journals, archive and all, to be able to see papers from other areas. When you subscribe just to the journal before and just that journal, then that was that was what you knew. And of course, serendipity, which is discovering something accidentally, which you would not have otherwise seen because you're thumbing through a journal. I think that's one of the roles of the journal. This is, of course, very important, I think remains the most important, that the fact that a paper has been published in a journal as opposed to existing on the archive alone means it has a stamp of validity. In fact, my colleagues in high energy tell me that when they look at a paper that has sat on the archive for a very, very long time and has not been published, they look at it suspiciously. So this is kind of one of the quotes. It's not just true of journals, this is also true of the whole publishing, the newspaper world and so on. This is that you're not buying news. In physics, it means it's not the knowledge of the existence of the research. It's more of the stamp of whether the research is valid and important. That's part of it. All right, so this is the last slide, I believe, before I finish off. This is just generated by somebody. So this is what is happening from Spain. So this dip, not sure what happened. Seems to be real for some reason in Spain in the year 2009. That's when PRL got stricter, but this is receipts from Spain. Maybe something new. Huh? You knew, that's right. But I don't see, but you can see the published didn't show any dip. Maybe the quality, this is actually an uptick if anything. But anyway, so this is where we are now. My guess is this percentage will clearly drop for both. Okay? So I didn't answer some questions. There's a whole bunch of stuff that I didn't go into, but feel free.
What is the role of the PAX number as a physical astronomy ecosystem?
Well, the PAX number is something that was maintained by the American Institute of Physics for a long time. Very useful. I think a couple of things have happened. Well, the PAX numbers are no longer being maintained. They exist, but they're not being updated. So I think it was the problem could have been that it was very helpful, but it was much too granular. By which I mean that in some newly emerging fields, some individual would have to go in and decide how to bin things correctly, and that was work that they were not willing to put into. So the PAX numbers are being retired, or have been retired. They still exist. But even in physical review, you will see that some areas, the PAX exist, but they came kind of late. So for example, graphene, I believe, did not have any associated PAX in the year 2007, several years into the existence of graphene. So all papers that were being submitted that had to do with graphene were getting stamped with the packs of 2D materials or 2D transport or something, photoemission packs because it happened to be, so that was that. And also some current areas of hot research in, let's say, topological insulators. There is no packs for it because this field emerged in the last few years and there's no packs. So packs are being retired. Keyword-based approach will be developed. But on the other hand, from the author's point of view, in the age of being able to search in Google and all, I really don't know if packs, no one uses pack as an author. It's more for classification at the other ends. So packs are gone. They exist, but it's frozen in time.
You mentioned clearly the load that the editor having not only physical regulatory, I'm sure in any journal. But sometimes I have the feeling, and I think I'm not the only one, that the editor acts like a passive relay. Just receiving information from the authors, sending to the reviewers, receiving from the reviewers, sending to the author, and not being too much involved into the decision.
Right.
It looks like they count just positive, negatives, and most of the time the paper is rejected because you show the rejection rate is quite high. I want to know if that is only my feeling or is something like that really happens.
Well, we talked about this earlier. There are two ways to look at it. I think on the one hand, editors often do have, just to give you an example, the fact that the editors are rejecting 30 to 35% of the papers without review means that they're making very strong judgment at that initial step. We call it rejection without external review. So that's a clear case. So that's 30. Now, once the paper moves into the review system, we are more likely than other journals to let the reviewers kind of advise us on all aspects. So, in other words, we're not just asking reviewers to tell us if the paper is correct or incorrect. We're also asking them to tell us what they think about the paper in terms of its suitability for PRL. So that's information we want. So once that information comes in, it is not as if the editors are counting votes, so to speak, but they do rely on that information more than perhaps other journals because we are a community-driven journal, so we want the community to tell us what they think. With that said, especially with the recent changes, we are asking referees more and more to make, so assuming that they're telling us to publish a paper, we tell them that it is not enough to tell us that we should publish the paper, but they should tell us why we should publish the paper. So we might go back and try to, and I think it is happening on occasion that referees will tell us to publish a paper, but to the editor it's not clear as to why. In that sense, the editor is unable to figure out why the referee said yes to the paper, then we think it's not a positive recommendation. And in those kind of cases, the editor may make a judgment which will differ from other referees. So, and another corollary, many PRLs, not most, I don't know the numbers, are published over the strong objection of maybe one referee, at least one referee. As you will have all received, we try to send you all the other reports and the various chain of sequence of events that happen. So as a referee who said, don't publish, we want you to hear from us as to why we publish the paper rather than just have it appear on the journal at some point. So.
Would you make a referee report for physical review? In addition to the report itself, we have to fill in a form saying how important is this paper to the field and so on. And this is something which is accessible only to the editors.
Right.
But to me, somehow it seems that some reports do not seem to be so negative from the editor's reaction. So this is because you check this form, or?
Well, we check it, but
yeah. So would it be more clear if the authors could see also this report?
well, but the problem with that is, I think we do it. I forget the various reasoning we went behind, but I think in many cases the way the forms are ticked, marked off. Sometimes it's orthogonal to what the report is saying. Sometimes it is on a scale which is relative to the paper, relative to the field. Some people are marking it on a scale which is relative to all of PRL. So, it's not so it's a scale-based approach, but it's not on an absolute scale. So it's sometimes difficult to parts. I mean, we've talked off and on about sending it, and we do factor it into our decisions, but we don't. I think one of the reasons is that form gives the impression of being some kind of a precise metric, which it is not. And so if you're as an author, you receive that and it has a bunch of ticks on the right-hand side and nothing on the left-hand side, you'll say, oh, it's positive, you know. But to us it seems yes, but the report doesn't make the case, and also it's positive only because this referee's last 10 reports have ticks in the same place. You know.
More questions? Well, I have this one. What is the impression of the editor when the authors have to reply the reports and they take long time, months, for instance?
Authors?
For instance.
Well, I mean, we don't have a
This
limit.
can happen. I mean, not only for the reviewers.
We don't have a limit on that kind of thing usually.
Yeah.
We have had cases where papers are submitted a year or two later, but then the bar gets increasingly higher, right? Because if you're submitting it after 2 years and there has been no demonstrated interest in the field in those 2 years in the topic on which your paper is, then it makes more difficult for you to make your case. If you're going back and you're resubmitting something because you went back to the lab or did your simulations again, that's perfectly allowed. We'll assign a revised date usually, and so it will be clear to the whole world that it was submitted in January 2010, resubmitted in February 2011 or something like that. So that we will do. If it takes much longer, one exception is comments and replies. That's a very specialized subset. There we're very strict about being timely and so on. Because
competing journals within American Institute of Physics, Physical Review X, and outside.
So this is very interesting, right? So firstly, for Physical Review X, so Physical Review X was started a couple of years ago because the American Physical Society felt that it needed to have a broad open access journal. So we have open access journals before, but they were very specialized in certain areas like physical review, special topics like accelerators and beams. Those are special. So as some of you know, there seems to be off and on pressure to have fully open access, what are called gold open access journals. It's unclear at this time as to how that will work out. But APS felt that it needed an open access journal. So that's how it was initially formulated. But then there was some thoughts among various parties that this journal should not be, it needs to be a selective journal. Broad, but selective. Now, as I said, that's extremely difficult to do. You can be selective, but then you won't have breadth. If you breadth, then you don't have selectivity. So at this point, I think Physical Review X, their aim is to restrict about 200, 250 papers a year. Their submissions are small, but possibly growing. It's unclear what will happen if the submission rate will go at a much larger number. They have had very good success and good papers in certain areas, but those are the traditional kind of condensed matter and atomic and molecular physics. And then you have the issue of areas such as soft matter, what they will do, what they're receiving, and what would they do on other areas where the thinking behind open access journals is very different. So for example, for high energy physics. The high energy physics community has philosophical differences as to their point of view of vis-a-vis open access journals compared to other areas and so on. So it's ongoing, they're doing very well, but it's not quite steady state yet. So we'll see. Now for PRL's position is, we have competition in-house, we have competition from outside. We have the 4 charges that I showed in terms of balance that we want to stick to. At this point, we are large so that there are many subsets of PhysRev X, if you will, within PRL. And we want to keep it that way. We don't want to become exclusive also, not everybody. So, but on the other hand, we are, and the other competition, of course, is from journals which are extremely exclusive, Nature, for example. And then you have journals such as Nature Communications, which are not just physics, so there's an issue there. And then your physics competition, so nature physics, for example. But that's similar to that broad. So we don't, PRL's position is that we are the only exclusive, broad-based, therefore large, physics journal. There isn't any others. In fact, just to show you, if I have the plot, let me see if I can find it. That's not a good one. Here, I'll show you this one here. So this means, you can see the impact factor we have here versus the journals. Right? So these are various journals. These are mostly physics journals. All physics journals, actually. And you can see there's PRL right below the arrow. So we're sitting in the sweet spot of a fairly high impact factor, but with a huge number of articles. So and we like that sweet spot, if you will. So we want to be selective, as defined by the impact factor or any other metric, but we don't want to be small. We don't want to be a boutique journal. So that's where we are at this point. So that's our, then I think we're doing it pretty well. I mean, the fact that we have reduced from about 80 papers a week to roughly 50, that's a conscious decision. We don't think we want to go to a significantly smaller number, because that would mean us having to decide to jettison papers of this or that field, which is a very different kind of balancing act.
So the editor reject, let's say, 30% of PRL papers. Do you follow what happens after? Do you check where this paper will publish and if
We periodically does that, not on a regular basis. So, well, we clearly know the numbers of them that go to physical review, B or one of the other physical journals. Those numbers, we have pretty high numbers. So we have clear, I forget the exact percentage of that subset. I know the full percentage of papers that are reviewed and rejected, and but you're asking specifically about papers that are reviewed without being rejection, and a large number of them go to physical review, but not all. And I think it's not an ongoing calculation that we do, but people have looked at it to see. There have been a few papers that have particularly gone to applied physics journals and have done very well. But yeah. But in general, overall, if you're asking whether there are a substantial number of those papers back with 2 years of hindsight and say, oh, very few, very few. We have rejected papers after review, though. That we have regretted rejecting, and we have even papers, we have cases of papers where all referees were negative. Just recently I saw one. All referees were negative. We went through a process. It went to a divisional associate editor, and the divisional associate editor wasn't quite sure, but he felt we should publish it. And this is one of the highest cited papers in the last 2 years. So things can happen. So the review process could be problematic. But
I'm just wondering, you have the data about institutions.
oh, yes, I have it. I can see that if I can. Now, oops, that's hidden, sorry. I have to bring it up. This is the one you want to see? Now I see here, now what is unclear to me, as I was telling Rosa, is somebody generated this for me.
No, this is not correct.
This is not correct, I think, because it does not include the, right. So I wonder if some of the others, this is why I hid it, I didn't show this earlier. Now, of course, the other thing is, the other problem we have with this, and I think we talked about this with somebody, is if these institutions have 1 or 2 people in some large high energy collaborations, that's it. That's taking care of, many, many submissions. So, of course, then you could say, oh, we can normalize it by taking away the high energy collaborators. But then, is that fair to them?
Yes.
So if you want to get a lot of PRLs the trick is to get at least 1 or 2 of your faculty members be in some large collaborations.
Now, what happens in this table is that you've seen this morning our physical regulators of 2013, and they appear jointly as this university and the Consejo Superior de Investigaciones Científicas.
Some of the 19 and
Yeah,
the third place
there is an
are
overlapping.
Yeah.
You don't identify the institute.
Okay.
There
Yeah,
could be
so that
some
could be,
overlapping.
Let's see,
I mean, I did a quick search and I found 9.
9
instead of 5.
at this?
Yes. And 8 of these 9, by the way, from this institute.
So what you should do, so yeah, so this is, I think what the guy who ran it, it's, he basically just ran it down the author's list, right? And that's the keyword he's looking for, and I think it could be that some of the others are, this gives you a rough idea. So this one, pretend it's not there when you do your thing, because it's probably incorrect.
They have a lot now.
Take the last question.
As I understood, you marked, for instance, for the referees, you have points, which are good references.
Yeah.
Do you do the same with editors somehow, or not?
We do have, editors are always getting feedback. Numerical, this, that, the feedback could be everything from the amount of actual work they're doing to the acceptance rate. Every month they get a thing showing the acceptance rates, papers coming in, this and that. So yeah, editors have pretty good feedback. And of course, just like authors, they will rationalize, right? So some editors will say, my acceptance rate is high, but that's only because I handle papers mostly in high energy physics. So you have to think about that. But yeah. So, but it is not that they don't have information. Everything is, lots of data-driven information is at their fingertips at any moment. So, and in fact, I mean, they even have the citation profiles of papers that they okayed.
So, well, just a small announcement. We have moved the informal talk for tomorrow at 11 because there is a meeting before. Okay. So then for the students and how to write a nice paper.
They will announce it.
as a talk.
Yes. So then let us thank again.
Okay.